1 minute ago, a signal arrived on Earth that took 23 hours to travel here. It came from a machine built in 1977, a machine older than the internet, older than the mobile phone, older than almost everyone watching this video right now. That machine is Voyager 1, and it just sent back something that has left NASA's own scientists staring at their screens in silence. Because Voyager 1 did not just leave the solar system, it turned a corner into a region so strange that the laws of physics we grew up trusting seemed to bend right in front of it. And what it found there is something nobody predicted, nobody modeled, and nobody can fully explain. Stay with me for the next few minutes because this story is not science fiction. It is happening right now, 16 billion miles from where you are sitting. And by the end of this video, you will understand why some scientists are calling this the strangest environment humanity has ever touched. Let's rewind for a second, because to understand how strange this moment is, you need to understand what Voyager 1 actually is. It launched from Cape Canaveral in September of 1977, built with less computing power than a modern calculator and sent on a journey that would outlive almost everyone who built it. Its first job was simple by comparison. Fly past Jupiter, fly past Saturn, take pictures, send data home. It discovered volcanoes erupting on Jupiter's moon, Io, the first active volcanoes ever seen outside Earth. At Saturn, it uncovered new moons and revealed that Titan was wrapped in a thick, hazy nitrogen atmosphere. By 1980, Voyager 1's main mission was finished. But instead of going quiet, it kept climbing outward, away from the sun, away from everything familiar. And it never stopped sending data back, even as the decades rolled by. If you're new here, this channel goes deep into stories like this every single week. So make sure you hit subscribe before we continue, because what happens next in this story is where things get genuinely unexplainable. In 2012, something historic happened. Voyager 1 crossed a boundary called the heliopause. Think of the heliopause as the edge of the sun's bubble, the invisible wall where the solar wind, the constant stream of particles blasting out from our star, finally runs out of strength and gets pushed back by the pressure of the wider galaxy. Crossing that boundary meant Voyager 1 had officially left the neighborhood of our sun. It had entered interstellar space. It became the first human-made object in history to leave the solar system entirely. You would think that once it crossed that line, things would simplify. Empty space, cold and quiet, stretching out forever. That is what most scientists expected. That is not what they got. Almost immediately, Voyager 1's instruments started returning numbers that did not match any existing model. The direction of the magnetic field around the spacecraft was off by more than 40 degrees compared to what researchers expected true interstellar space to look like. 40 degrees is not a rounding error. 40 degrees is a sign that something about this region does not behave the way the textbook said it should. For years, this anomaly puzzled the very scientists who built the mission. Some suggested Voyager 1 hadn't actually left the solar system's influence at all, that it was sitting in some kind of transitional zone, neither fully inside nor fully outside the sun's reach. Others described the magnetic field out there as being bent and distorted, like a rubber band stretched and wrapped around the invisible edge of a giant unseen sphere. The image scientists eventually settled on was almost poetic. They said the interstellar magnetic field was being deflected around the heliopause the same way a river bends around a rock. Except this rock was our entire solar system, and the river was the magnetic structure of the galaxy itself. That alone would have been a strange enough discovery to end the story. But Voyager 1 was just getting started. In 2013, using its plasma wave instrument, Voyager 1 detected something scientists were not expecting to hear at all: a persistent low vibration in the ionized gas surrounding it. NASA described it almost like a hum, a constant tone humming through the emptiness of interstellar space. It wasn't noise from the spacecraft, it wasn't a malfunction, it was the sound translated into audio from electromagnetic data, of the interstellar medium itself vibrating in a way nobody had ever recorded before. Imagine that for a second. A machine built in the 1970s, flying through a region no human has ever seen, quietly recording the ambient hum of the galaxy beyond our sun. Then, in 2020, something even stranger happened. Voyager 1's magnetometer, the instrument that measures magnetic fields, registered a sudden and unexplained spike in magnetic intensity. At the exact same time, its plasma detector recorded a jump in plasma density around the spacecraft. Scientists call this event a magnetic hump, and it wasn't a one-time blip. It lasted for months. The leading theory is that this magnetic hump was caused by a massive wave of solar material blasted outward from the sun years earlier, finally slamming into the outer wall of the heliosphere and rippling outward into interstellar space, compressing the plasma and intensifying the magnetic field far beyond where anyone expected solar influence to reach. In other words, the sun's fingerprints were showing up in a region that was supposed to be untouched by our star entirely. Researchers have continued tracking this same disturbance for years since, and recent analysis released this year shows it still has not fully returned to a stable baseline. Some now argue Voyager 1 may have entered an entirely new equilibrium region, a genuinely pristine pocket of interstellar space that behaves differently from anything measured before. Others disagree, and the debate is still ongoing in published research right now in 2026. This is the part where I want you to really sit with what's happening. We are talking about a spacecraft so far away. A radio signal traveling at the speed of light needs almost a full day to reach it. And still, scientists cannot agree on what it is flying through, not because the data is bad, but because the region itself refuses to behave the way physics models predicted. And here's where the mission is about to make history all over again. In November of 2026, Voyager 1 will cross a distance milestone unlike anything ever achieved by a human-made object. It will become exactly one light day from Earth. That means a radio signal, moving at the fastest possible speed in the entire universe, will take a full 24 hours just to travel from Earth to the spacecraft, and another 24 hours to get a response back. The Voyager project manager at NASA's Jet Propulsion Laboratory described it in the simplest possible terms. If she sends a command on a Monday morning saying, "Good morning, Voyager," she will not hear the spacecraft's reply until Wednesday morning. 2 full days, just for a single hello and a single reply. One light day is about 16 billion miles, or nearly 26 billion kilometers. To put that into perspective, that is 5.5 times farther than Neptune, the outermost planet in our solar system. And Voyager 1 has only traveled 0.0027% of the distance to the nearest star beyond our own. It is unimaginably far from home, and it is still somehow sending signals back. But here's the twist almost nobody talks about. While Voyager 1 pushes further into this bizarre zone, it is running out of power. Its onboard generators convert heat from decaying plutonium into electricity, and that power source loses about 4 watts every single year. It's not a dramatic countdown, but it is relentless. Slowly, one by one, NASA engineers have been forced to shut down instruments just to keep the spacecraft alive long enough to keep sending data home. In February of 2025, the cosmic ray subsystem was switched off. In April of 2026, engineers shut down the low-energy charged particle instrument, a tool that had operated almost continuously since 1977, nearly 49 years of uninterrupted data, silenced just to conserve power. Today, only 2 of Voyager 1's original 11 scientific instruments are still active, the magnetometer and the plasma wave subsystem. Those are the exact 2 instruments that detected the strange magnetic anomalies, the interstellar hum, and the unexplained magnetic hump we just talked about. The very tools still capturing the mystery are the last ones left standing, and even they won't survive forever. NASA engineers have not given up, though. Earlier this year, they began testing a bold plan on Voyager 2 first, since it currently has slightly more available power. The idea is to see if certain shutdown systems can be safely reactivated using a different power management approach. If that test succeeds, engineers hope to apply the same method to Voyager 1, potentially bringing a previously silenced instrument back online. Nobody knows yet if it will work. But if it does, it could buy Voyager 1 more time inside the very anomaly that has puzzled scientists for over a decade. And that raises the real question hanging over this entire story. What actually is this region Voyager 1 is flying through? Some call it the true edge of solar influence, a kind of transitional pocket where our sun's magnetic fingerprints still linger even this far out. Others believe Voyager 1 has now pushed beyond that, into a genuinely pristine stretch of interstellar space, untouched by our sun in any way, and that the strange readings represent something entirely new. A structure in the galaxy's magnetic field we simply never had a way to measure before because no human instrument had ever traveled far enough to reach it. Both explanations are backed by real published research, and both are still being debated by scientists actively working on this data as recently as this year. That's the part that should give you chills. This isn't a settled mystery from decades ago. This is happening in real time, with new papers, new models, and new disagreements being published in 2026 about a spacecraft that is still transmitting. If you're the kind of person who loves stories where science and mystery blur together like this channel is exactly where you want to be. So tap that subscribe button and turn on notifications, because we cover discoveries like this the moment new data comes in. By most current estimates from mission engineers, Voyager 1's power supply is expected to drop below the operational threshold sometime in the early 2030s. When that happens, the spacecraft will not explode, will not shut off dramatically, and will not stop existing. It will simply go quiet. It will keep drifting outward at 38,000 miles per hour, carrying its golden record forever, but it will stop talking to us. That golden record deserves a mention. Bolted to the side of the spacecraft is a gold-plated copper disc designed under the direction of Carl Sagan, containing greetings in 55 languages, music from across human history, and a map showing Earth's location relative to nearby pulsars. If Voyager 1 ever encounters another civilization millions of years from now, that record will still be there. A small golden whisper from a species that once looked outward and wondered what was out there. So here's the real question I want to leave you with. As Voyager 1 pushes deeper into this uncharted zone, racing against its own dwindling power supply, what do you think it's going to find next? Do you think this magnetic anomaly is simply the last echo of our sun's influence fading into nothing? Or do you think Voyager 1 has stumbled onto something genuinely new? A feature of the universe we never had the tools to detect until one small, stubborn spacecraft finally traveled far enough to touch it. Drop your theory in the comments below, because this conversation is far from over. And if this story pulled you in the way it pulled me in while researching it, do me a favor and hit that like button. It genuinely helps this channel keep making videos like this one. Subscribe if you haven't already, because Voyager 1 is about to cross that one light day milestone in just a few months, and when it does, we will be covering exactly what happens next, live as the data comes in. 16 billion miles from home, a 49-year-old machine is still out there, still listening, still transmitting, still finding things we cannot fully explain. And somewhere in that quiet, cold, endless dark, it is waiting for its next signal to reach us. 1 minute ago, one light day away, still going.